Okay, good morning, everyone, or good afternoon. I would like to welcome all of you to our technical session. My name is Julia Kubanek. I work at ESA STEC in the Netherlands, and I'm looking forward to an interesting discussion regarding the sessions we had in the last days, so yesterday and today, on earthquakes and tectonics in for the built environment, subsidence and deformation. We are going to start with the earthquakes and tectonics. And I would introduce for that the session chairs from yesterday and today, who were Masato Furuya, Marie-Pierre Duin, Sigurjon Johnson, Henriette Suthaus, Paul Landgren, Andy Hooper, and Tim Wright. Not all of them can be online today, but I just wanted to mention the name because it's always a huge effort to share a session. And I would like to remind you that if you want to ask questions, please use the questions and answer tool in WebEx, or you can also raise your hand and then we can unmute you that you can pose your question. So I hand over now to the earthquake and tectonics team, and I try to keep the time for roughly 30 minutes per topic.
Thank you, Julia. So I'm the one to moderate this technical session for the earthquake and tectonics group, let's say. So we have Tim in the background and Masato who will take notes, because this is now the time where you can pose like general questions or general recommendations, even better, to ESA for what you think as a user could be made better, or maybe in a different way. So we sat together and came up with some seed questions to maybe stimulate, to not have it completely open. So I encourage you to think about the questions that we post here on the slides, and yeah, use the question and answer tools. I think do we have the possibility, Julia, to also for the microphone that
Yes.
people...
Yes,
okay.
the people can raise their hand and then we can unmute them.
Yes, even better. So some things are hard to type, or we maybe want to come into a dialogue. That would be very nice. Yeah, for this topic, because we have this summary session, but not only that, we are compiling a document with recommendations, and we are awaiting input also from your side. Okay, let's start. So we have a first question. We ordered them like we thought maybe is good. You know that we have this this mask for tectonic areas, where we asked ESA to have frequent acquisitions and also from 2 look directions from ascending and descending, such that we can best monitor these regions. The question is now, what do we feel? Is that a good mask? Do we need to review this mask, or are there areas that are maybe not covered well enough from our today's perspective? I was just thinking, please raise your hands. Is there someone who can help me with a question and answers, or do I have to?
I can help you, Henriette. So
Okay.
I can read them, but there are no questions yet.
No questions.
I think there was a comment from Marie-Pierre, who can't be, sorry, no, from Cecile, I think, regarding this question that she sent by email, which was about whether there was a tool for detecting acquisition gaps. So even though we've obviously got the tectonic mask, there have been some gaps in the past in Tibet and places. So it would be useful to monitor the kind of existing plan, just to check that everything is automatically acquired. So there's no one here to answer that question, but I think it will be a useful thing to have, I think, some kind of tool. From our perspective, the tectonic mask is pretty good, but we'd obviously like ascending and descending every 6 days everywhere, but we know that's not possible, and I think that what we have is a reasonable compromise. But it may be that I think it's important, if there are areas that aren't covered, that people let us know, and this is a good forum for doing that, and we can also pass that information on to ESA as a recommendation.
Okay, very good. So is there something that so apart from this, is there, we were wondering if we could use other imaging methods. Yeah, like for instance, the extra wide swath. So I'm not sure if Johnny is here, but he said that, for instance, for the high latitudes, it could be, so this should be made available maybe sooner. There was in the Iceland crisis, there were some problems, maybe some not good coincidence. But are there other recommendations maybe from the user side about this extra wide swath data that are acquired when they are overland? Is that something that people would appreciate to put in better use? Okay, maybe this is also a too very, let's say, very precise question, and not so many feelings about this.
Here. We had a similar request in the infrastructure session about the EW, and this is at least to provide on demand the SLC processing of these scenes. So a lot of images are acquired. You have the raw data on the archive of GRD, but not the SLCs.
Yes.
And so the recommendation would be to have a method just to request SLC processing by ESA for a certain number of these scenes.
Okay, this sounds good. I think we can second that recommendation, also from our community. That's very good. Thanks, Tasio.
Okay, so now we are also getting raised hands. Marie-Pierre has raised her hand. I'm not sure whether I can unmute or if Ulla has to do it.
Excuse me, we can do it if it's a message for Marie-Pierre. You have to enter with the desktop version of WebEx because you are now with a web browser application. Sorry, Marie-Pierre, if you can log off and re-enter again. Thank you very much.
Yeah, and I think it's similar for Sione because he's
Yes.
also asking a question, but you could also re-enter as a panelist.
Exactly. Thank you very much, Julia.
Okay, so we are waiting until they're back and going to.
In the meantime, could I just make a comment on the second point? I mean, I don't know how many extra wide swath are acquired over land, but obviously most of it's over the ocean. So if SLCs were made just for those bits over land on a regular basis, actually, that might be quite helpful rather than having to request it.
Okay.
Okay, and Pablo Gonzalez is asking or stating and asking at least 2 papers at Fringe reported the usefulness of the burst overlap interferometry. Could we accelerate methodology development if ESA could distribute the burst overlaps as products to facilitate processing and product quality improvements for azimuth precise offset per orbit? Maybe shall we unmute Pablo that he can raise his question himself because it's quite a huge chunk of information.
Hello?
Yeah, you should be able to speak now.
Okay, so I was very encouraged by the results by Kausta and also in Leeds about the potential to use north-south or detect north-south movement. And I remember as well on my participation on the FRINGE project how much time it requires to find very precise offsets for precise registration of SLCs. And I was wondering, maybe we could suggest that burst overlaps will be it's separate SLCs, so very, very small ones, and people could probably focus on just make improvements using those products to obtain better offsets or movements without delaying production because they need to download all the SLCs on itself. Another option will be as well, as Piyush was presenting the first days, to get annotated and tools to extract course overlaps directly from the zip files.
Yes, thank you, Pablo. Is there any comments from our panelists to that, or are we just taking this on? Okay, I think we just so we heard this, and it seems like a good idea, and a question that, sorry, was there someone? No. One question that we had, if there's a more service needed for atmospheric and ionospheric signal reductions that ESA could help us with. What do you think?
It looks like in the chat, Ramon Hansen has some comments on this question and the next question. So I don't know whether we can bring him in. That would be great.
Yes, I can unmute him.
Hi, Ramon.
You should be able to speak now.
Ramon, you have to unmute yourself.
Is Ramon there? I think maybe before Ramon jumps in, I think it would be useful to have these correction fields mass produced. Either, obviously they're not necessarily standard yet, but if there was a way of mass producing those corrections and providing them with, ideally you provide them with the data or in some other repository, I think that would be really useful for the community. I think certainly in the Comet Lixar group, we're planning on at least providing some corrections alongside, GACOS corrections, for example, alongside the in our data store. But I think there are other things that could be done routinely. Is Ramon in yet?
He should be able to speak. He seems to be unmuted.
Ramon, if you can speak any time if you like to, and if you hear you, keep trying.
He's writing. He is speaking, but we cannot hear you. Yeah, against the wall. So okay. But there was another comment on question 3 from Richard Walters. Better uncertainty estimates associated with atmospheric ionospheric corrections to facilitate proper error propagation associated with corrections.
Yes, so it sounds like we would like to have that. So similar to the
Yes.
to the GACOS services, something also for the ionosphere would be great. And yeah, what Richard also just said, such that we can either incorporate this or we can correct this to some extent. Maybe. So Ramon, yeah, you can any time. What about these mass processing results? Is there a need to make this somehow more useful? So we have seen nice presentations also on Monday on some on some new services. Is there something still missing that we feel, or that could be made even better? Okay, wait.
Maybe you can hear me now?
Yes?
Yes.
Cool. Yeah, okay. Yeah, thanks for, I was just wanted to make a short comment, just an idea, a very loose idea on question 3 and 4. So in my opinion, what we see more and more is that many different institutes and groups want to work with bigger data sets. And therefore, there is this problem of I/O. And in my view, most of the people in this community would like to do their own type of processing, especially in terms of atmospheric correction or multi-looking yes or no, or they want to advance things. So I don't see that much opportunity, let's say, to come up with very higher order products. But I do see a very interesting or low-hanging fruit in, let's say, the co-registration part of it. So would it be an idea if ESA would simply already do the co-registration of the images so that everything is in a co-registered stack and that the data that are downloaded do not need to go through local co-registration processes anymore?
Yes, I think this was also raised on Monday, but I think for this community, yeah, this would be a good thing.
And also Marie-Pierre wrote her question now, is it possible to download burst only without downloading whole data sets? I think it relates to also facilitating download and processing.
And it's more than only facilitating the download. Yeah? So I think this would be quite an endeavor. But I think it would be, let's say, the least invasive type of step that would really help really considerably, because you don't need to do. So yesterday I had a talk with the Delft University IT people on the needs that we have within the university. And apparently our group is one of the main users of disk space, basically, because of all these satellite data. So that will not be different from many other users in this panel or in the world working with INSAR. So if you don't need to kind of store data temporarily, so let's say not the reference image, but then what we used to call the slave images. But if you would immediately have those in a co-registered format, that would save an enormous amount of disk space and therefore faster I/O, more applications. So could we put that as a recommendation to ESA, for example?
To me, it sounds good. Thanks, Ramon. So,
can I just comment on that? I mean, I also think that's a great idea. But just to say, it's not mutually exclusive, of course, with having other auxiliary services. And I mean, there was this talk on ETAD on Monday. I don't know if those products are going to be made generally available, but it sounds like there are already some moves to make some general atmospheric and ionospheric models. I don't know if anyone here can comment on that.
Can we please also unmute Carsten Spahns and Christoph Giesinger? They both have questions or want to contribute.
I think it's also, yeah, as I was also going to just comment on the first thing that Ramon said, and I think the community is very broad now in terms of people who are, real expert INSAR users through to people who just want, they're really earthquake people who just want to look at the results and really don't care how they're processed. So I think having, and that's, I think, changed quite a lot in my lifetime with working with interferometry. So I think there's a role for having things done automatically and without users having to think, as well as making sure that there's the option for people to do their own processing with their own algorithms and their own corrections and develop new ones. I think both are going to be important going forwards. Sorry, was it Ramon, or was it Carsten wanted to come in?
Yes,
yeah,
Carsten.
I just wanted to raise Marie-Pierre's point again on more granular download options. I think we regularly have to download 7 GB files and a few hundred of them to extract tiny area. Bursts are a natural way of subdividing data products further. So a burst product in the future, I think, would help ESA as well with their bandwidths, would help us with our disk space further as well. And the co-registration, I think I would echo that as a great idea as well.
yes. So saving time, saving power, saving climate. Very good. Was Marie-Pierre there to say something, or?
This is Marcus. Can you hear me? I had some microphone
Yes.
issues. Yeah, so just to jump in the middle for about DTAD auxiliary products. So the idea is that in the future, near future, all acquisitions will be joined by this small auxiliary product that will mark files that are strongly affected by ionosphere, and there's also corrections for troposphere coming from ECMWF. So hopefully that will answer some of the concerns of the community. So I put the link into the chat, and this is becoming a reality. Unfortunately, I don't know what the exact date is when this is coming to production, and Nuno or Bethlehem are not part of this panel, so but I can get back to you on that.
Okay, thank you. Just to move on a bit, maybe in the question, we asked ourselves. So we have these mass processing results for earthquake and tectonics. We have seen fantastic images and results based on leaks, or there's ARIA. We are wondering also, if you do your own product, is there, for instance, the NSBAS, is there a time that we should maybe compare these results, how much they agree? And there's also the question how. So this is for ESA. Is that something that ESA should maybe like steering? So this would be something like a benchmarking, I think. Is it time for that we make sure that our processing are somehow comparable? Are there comments to that?
I think it'd be useful. I think it's been done on the kind of small scale on several initiatives on the kind of PS scale with with I think useful outcomes. I think doing it on the larger scale when there are different kinds of issues, over how you deal with long wavelength signals, those kind of things, which don't affect the smaller scale processing concerns. I think it would be useful. What I commented when we were putting that question together is that people don't do it because it's always much more interesting to just go and look at a new area and see what the tectonics is than it is to do this kind of important comparison work. But by doing this, you do learn, about what you're doing well, what you're doing, what you're not doing so well, and I think will be really valuable to do. I think some funding from ESA would help motivate people to do this.
Okay, so we want this, but we know that we need motivation, or what?
Yeah, I think there's always more. Well, it's not that it's not interesting, but there are always more fun things to do, I think, with the data. But it's an important activity that I think there's enough people would support doing it that we should do it, even without funding.
We have again two people raising their hands, so Marie-Pierre again, and also Carsten Spans.
Marie-Pierre?
Sorry, I still have my hand up. I just forgot to put it down. So.
Okay, Marie-Pierre, you want to add?
Her
something?
audio doesn't work, I think. She's got audio problems.
Okay, but she also wrote something in the chat again. Henriette, do you want to read it yourself? It's in this chat and not in the questions and answers.
It's in the chat. Yeah, I think this is it again to the burst, or is it an old one?
No, it's like for atmosphere, we often correct with ECMWF models. However, below the ECMWF surface in deeply incised valleys, the correction is not accurate. So I think she wants to interact with ECMWF guys for them to produce nice below the earth extrapolations or facilitate access to higher resolution models for individual countries.
Okay, great. Maybe Tim, you can copy that. So I cannot see it in the chat. Maybe I'm too stupid.
Okay, sorry. Yeah.
Yeah.
Yeah, I've copied it.
Very good. Very good. Maybe then for the last couple of minutes, maybe to more fun stuff. We've heard that when Sentinel-1C is coming. So first of all, when it's coming, so when it's launched and when it's turned on, actually for us to use, this is something where we think from the we also said this at last Fringe 2017, as if Sentinel-1C is up there. I think we all would like to have it turned on. I think this is a no-brainer for us, maybe. The question is of the constellation flights. So on Monday, I learned that the idea is at the moment that the 3 satellites then would fly in what is it, 120-degree distance, so that we have these acquisitions every 4 days. Is that the I think we framed it the most boring configuration that you can have, but maybe it's the best one. And the question is, if we think that maybe something like 2 normal distances and 1 very short, like a day repeat visit, is something that people would like to see for some applications. I'm not sure if this.
Can we please unmute Pierre Potin? Thanks. Not sure if he wants to contribute or has another question, but he raised the question.
Yes. Hello, can you hear me?
Yes.
Yes.
I just arrived as observer. Yeah, I mentioned in this presentation that most probably, actually, it's almost sure now, we will not operate more than 2 satellites nominally in orbit because of constraints on the operations budget. If we want to stay in the available operations budget, we cannot afford to have the full operation of a 3rd satellite. So we have been analyzing the constellation of 3 satellites, but considering the budget available, we will stay with the baseline that we have today. And we will have the 3rd satellite in backup, in orbit storage. So we are a bit disappointed, I must say, and would have preferred to have 3 satellite constellation. But it's if we start like that, it's a commitment for the long term, and then we'll have the new expansion missions coming, Roselle and so on, and the situation will become very difficultly manageable in terms of operations costs, because we have an envelope, and today the analysis show that we cannot do more than the baseline of today for Sentinel-1, 2, and 3, which is 2 satellites in operations.
Okay, thank you, Pierre.
And also Durand wants to speak.
Okay.
Sorry, Henrietta. Maybe not.
Maybe not.
Philippe Durand.
And maybe just quickly before that. So if a 3 satellite constellation is not going to happen, then the question 7 is more important, because we have heard of some missions that would accompany Sentinel-1, and then this is the next best thing. Do we have recommendations how they should fly in, for instance, in some bistatic mode with Sentinel? Or what we would like to see for such missions.
Could I just clarify with Pierre whether does that mean that the Sentinel-1C won't even be launched, or would it be launched and just doing nothing?
So sorry, I was interrupted. You said about 1C?
Yeah, does that mean it won't even be launched? Or I just wondered, would it be launched and just sit there doing nothing?
No, the plan is, we have assumed, the nominal lifetime of the Sentinels is 7 years. We have assumed that then for the long-term scenario that it would be 10 years. Now we will launch as planned the next satellites, so Sentinel-1C. Since Sentinel-1C has some new capabilities like an AIS payload, it will basically replace Sentinel-1A. And we still need to analyze and see where we will locate 1A in case of a major let's say, anomaly on 1C or 1B. So we will, and then we will, when we will launch 1D, which is a bit later, because we will put it in storage, we will deorbit the oldest one, 1A. So all this is to be, let's say, analyzed in detail. But honestly, I'm not, let's say, we will not abandon maybe the idea of making use of the satellite in case of an emergency, but this is not the deadline today. For instance, to for more information, more observations. But definitely the baseline is 2 satellites in orbit. So, and you know, Sentinel-1A was launched in 2014. Soon, the time we launch Sentinel-1C, it will be early 2023. Then there is the commissioning, and then we arrive at a stage where Sentinel-1A will have 10 years already. Time is flying.
Okay, thanks for clarifying.
Thank you.
I think the excitement of having, you know, in the future, kind of having Roselle, or you know, so you're having the 4 satellites in a nice configuration is really something to look forward to as well. I think in terms of this question that you've posed, question 7 about future missions, I think there's been several comments on this in the chat as well, but I think the north-south motion is really important for the tectonic community, and I'm sure for other communities as well. And so whatever happens with future mission designs, but also with the Harmony mission, to make sure that we do get these north-south motions. I think Harmony is going to give us hopefully some fantastic north-south data, but it's only for 3 years. So thinking beyond that 3-year time window, and what could be done with Sentinel-1 next generation on the north-south would be something to think about.
Just to clarify, that in the plan there will be 5 years of north-south from Harmony, but indeed having something operational would be great long term.
Okay, in the Harmony talk they had 3 years, but they had is in cross track for two of the years, and a long track for 3. Anyway, 3 years.
That's correct. But even when it's in the cross track mode, you can actually still get north-south motions too. Not quite exactly. Yeah.
Okay, I'm a bit unhappy to interrupt the discussion, but I think we should round it up slowly and get to an end.
Yes, very good, Julia. Maybe I just encourage, if you have a point that was not raised, or you have some comment on one of these questions that we had here, you can contact us. As I said, we are compiling a document, so you can put it also in the chat. We hopefully see it, or someone else to copy it down. Thank you very much for your contribution.
Yeah, I also thank all the panelists for moderating and guiding us through these questions. Yeah, as Henriette said, please send the remaining questions or like discussion points. And I also the panelists please copy all the questions from the chat, because I was not able to read all of them. Maybe just have a quick look. Okay, then can we switch the slides to the next topic, please?
Yes, I'd like to make a comment to all of the teams. Please let us know who's going to present the summary recommendations later this afternoon. Okay.
Okay, thanks, Markus. Okay, then we move on for INSA, for the built environment. And this session, I'd like to thank again all the session chairs from the last days, which were Frick van Leyen, Francesca Signa, Zong Lu, and Alessandro Ferretti. Not all can be here today due to different reasons, but Francesca and I believe Alessandro will guide you through the questions. Again, please raise your hand, and if you have comments or questions, let me and the others know. Thank you.
Thank you, Julia, for the introduction. So yes, as you said, unfortunately, not all the chairs could join this session, but we put together these slides trying to summarize the key points of discussion and the key questions that we have as a community looking at infrastructure and using INSAR in this field. So just a very brief recap. The session included 2 oral slots and a number of interesting posters that were presented on Wednesday. So the messages that we try to summarize include information from all of them. So we try to put everything together. So in the bullet points is just to give you an idea of the number of topics that were covered only in these 3 slots. So we've managed to cover a number of key infrastructure types, including transport networks, so roads, highways, bridges, railways, and many more. There were significant contributions looking at monitoring utility networks, so pipelines, power lines, as well as the oil and gas infrastructure. Last but not least, the clearly built up areas, moving from the single building scale to city scale analysis, and a lot of applications on dams. So we must say, as a general feedback from this overview, that the community using INSAR for infrastructure has grown significantly. If you think about years back and past editions of FRINGE, we think the volume of contributions and also the quality of the contribution has improved incredibly. So we are very happy as chairs about the general content of all the sessions. So if you can move to next slide, we put together 5+1 seed questions with some ideas and key messages to discuss together with you, with everybody today from the different presentations. Alessandro, are you there?
Yes, yes.
Okay, so do we want to read our messages and then we can check if there is somebody in the audience willing to contribute?
I think so, because otherwise we risk running out of time. We have to leave a room also for the last, say, session about surface deformation subsidence. So I would start reporting what we found, and then of course people can ask or put, say, or trying to highlight specific topics.
Okay, I'll start with the first one. So our first seed question is about the need for high spatial and temporal resolution. Of course, this is not a surprise because infrastructure monitoring and anything relating to the built environment is looking at such fine detail that the whole community involved in infrastructure monitoring requires high spatial and temporal resolution data. So we found, based on the feedback from the speakers, that sometimes identifying targets, either persistent, permanent, or coherent targets on linear structures, could be challenging when using medium resolution data, for instance, data from Sentinel-1. What we found as a general statistic is that there were a number of contributions using Sentinel-1 data only, but at least 1/3 of the contributions were based only on high resolution, very high resolution data from TerraSAR-X, Cosmos Sky, radars or 2 ultrafine modes, and only 15% used both. So this is a clear sign, let's say, clear summary. We think that we need to push a bit more as a community working on infrastructure on the need for higher resolution. So our general recommendation is to increase, if possible, and this is something to discuss with Isa and the other panelists, increase the azimuth resolution of future radar mission, if this is something that is doable, technically speaking, because we know there are clearly trade-offs in the space agency sector, in the industry involved in satellite design and construction that need to be accounted for. We also have another point about the importance of high-resolution digital surface models, for instance, from LiDAR acquisitions or UAV surveys. We found that these models clearly help a lot to improve feature identification in time series processing. However, such high-resolution data requires and calls for high-resolution SAR data. So that's the overall set of information that we collected about this topic. So I don't know if there are already comments in the Q&A or in the chat. Is there anybody who wants to comment on those points?
I will leave.
Francesca, just a quick comment. It's a fact that the private sector is moving for very high resolution SAR data and will complement, say, what the national and international space agencies will promote in the future. So I think, of course, we correctly reported this because this was a request, something we really found in the people presenting in our sessions, but I think to a certain extent it will be natural to solve the issues by complementing ESA and NASA and say JAXA operations with also the private constellations.
Ulla or Magda, was there a comment from somebody from the audience? Somebody with raised hands?
Philippe Durand would like to speak. I just allowed him to speak. Philippe, you.
Yes, please.
I think he's still not able to talk. It was the same in the last session, and he also had a question, but or comment, and it was related, I believe, to the other topic. So I think there's nobody new who wanted to speak now.
Anybody from the panel, from the other sessions? Because I think this is like a sort of requirement of point that also links with many observations from the subsidence and the formation team.
I can see in the question and answer panel, there's a question from Philippe Durand.
Yes, you hear me?
Ah, yes, no,
okay,
yes.
great.
Yeah, okay. No, it's just to come back to the Sentinel-1C. Between no data at all and a few data, maybe there is some middle position. As far as you must commission the satellite first, and then being in orbit, you consume fuels to maintain it and so on. So why not open it for the community to certain areas where you need more data and so on. So it can be a limited amount of data, but that we must focus on, and not all the 12, 20 or 25 minutes per orbit of data. So maybe consider something intermediate that's not so expensive. That's the point.
Also, Peter Marinkovic has a comment. Sentinel-1 next generation already planned to be higher resolution, about 5 by 5 meters and wide swath, so also with a higher revisit time.
Yes, exactly. This is true, and it also links with another of our seed questions that we will show at the end. So thanks a lot for raising this. So let's say, so this is not mainly a recommendation, but just an okay from our community to say that this is a good decision in terms of infrastructure application. So we are happy about this decision that was done at higher level. Alessandro, should we move to next one if there are no other comments or nobody else willing to contribute?
So now Mahmoud Arikan raised his hand.
Fantastic.
You can speak now.
Hello.
Yes, we can hear you.
Yes, thank you very much. I seen a couple of Sentinel processing results, and I noticed something which we noticed also in Sentinel-1A, Sentinel-1B processing. I recall from Monday that Zhang, although he was looking at the amplitude offset, he noticed that bias from Sentinel-1B, and we also seen some oscillation on the phase observations when the Sentinel-1B is added to the processing chain. So I was wondering if other researchers or ESA side there's an explanation, or is it just us that see this signal? Thank you very much.
Anybody wants to comment on this?
Maybe somebody from ESA on the technical side of this point.
Pierre, are you still here?
Yes, I am. Yeah.
Yeah, if I understood the question correctly, there is, I think at least one of the issues is that there's a slight offset in geolocation between Sentinel-1A and B, and I think that I saw that those in the cyclic reports, but I don't know what is the plan, if there is any, to addressing those. Would you remember or no?
Well, the best is that the question is detailed and sent to the help desk that will then route to the relevant team, the MPC. I think is the best. Difficult to provide an answer in real time here. But definitely, if there are some issues between 1A and 1B, it should be monitored and tackled, definitely.
I think we can move to the second
Excuse
point.
me, there's another question from, sorry, they made me, they asked me as a host from MD. Is there any possibility to make the high resolution data TSX available free of charge? Thank you.
Is there anybody to start the layoffs in Airbus? No, I'm joking.
I can speak about the Italian Space Agency because I was working there until a few months ago. So I can tell you the Cosmos climate data can be available free of charge for research applications. So you simply need to put together a short project proposal like the ESA category ones, and you can get a good amount of data free of charge. And I think DLR has similar mechanisms to access the data, at least for research applications. I think there is a Majimo tag who wants to contribute. Can you unmute him, please?
Yes, Mahmoud, you can speak.
Maybe it was related to the question he had before and he didn't put his hand down after. Ah, now, okay.
Yeah,
Thanks.
sorry, I had a problem with the headphones. So actually I put the poster. Unfortunately, it's a little bit low resolution, but you can see the problem, what we observed when Sentinel-B is added to the Sentinel-1A processing chain. So
Yeah, the link is in the chat, so you can see the link in the chat.
Yes, there is somebody else who wants to speak. If you can unmute him, I copied his name across in the chat.
we can move to the second
No,
point.
there's no raised hand on my side here. Who is it, Francesca? I cannot see it.
Maji Mutag.
But was it in a private chat? He should raise his hand.
It's in the Q&A, and I copied his name across to the chat. So you should see his name in both places.
We don't see Francesca.
Okay, okay. Maybe Maji, you can type your comment or question, and we can read it as soon as he arrives.
Okay, I'm sorry.
Don't worry. Alessandro, do you want to move to the second one?
Sure. Okay, so in terms of maturity level of INSAR, of course we are improving. There are many applications of INSAR data for the civil engineering projects and also the oil and gas, because we touch also this field. But we think that we could do a bit more, at least in terms of education. Sounds strange because many people here started working on INSAR more than 20 years ago, but looks like this is seen still as a new technology, in particular within the civil engineering community. So one question could be how to include INSAR data or INSAR theory in civil engineering courses, because sooner or later we all hope that civil engineers will have to deal with INSAR data too. Okay. And second point, interesting at least to discuss, are we convinced that finally the community in charge of in situ measurements realize that INSAR is not a competitor, or in our day-by-day, say, activities, we still find this kind of these conflicts sometimes, even just thinking of the wording they use when they refer to Earth observation and so qualitative information you can get from satellite. This is the point. So for whoever wants to comment, even though I think the point number 3, Francesca, is the most important one, and probably could also be of interest for ISA and other the panelists. But here, okay, it's just a recommendation. Let's try really, whoever is working in the academia, let's try to work together, trying to at least pass honest, say, piece of information about INSAR, plus, minus, you can, you can't. But it's important for these young students at least to know, to have a certain level of exposure.
Let's move to the third one. I'm sure there will be people interested in contributing and commenting.
Yeah.
Yes, also the time is very short, right?
Yeah.
But we still had the question from Peter Marinkovic in the chat now, but it was to the first question, or like not to the first, but question topic suggestion for panel and audience. As one next generation dual or quad pole, what are opinions and thoughts, and can recommendations, suggestions to either be provided? It's just like maybe you take it up and it can be responded to later after the meeting.
Yes, I would say that recommendations can be provided, and I mean, if they're incorporated into the summary presentation later this afternoon, we will absolutely take them on board. And there was probably a possibility also, if this is too short a time to provide us everything by this afternoon, we can then do it the next few days via email. But I don't know what if the community would like to trade SWOT for a quad pole. It's always a question, and My understanding is that the baseline is still dual pole, but this quad pole option is being examined. Maybe Julia, you know better.
Yes, I think it's indeed exactly that. We will run a requirement study now in the next phase to see. I think it can be decided afterwards. Okay, so how many questions do we still have to go through?
4, but some are
Okay.
quite short. So that's we think with the other chairs that this is probably the most pressing issue that that we should address or think about as a community. So our question is about to what extent is INSAR capable to provide information suitable for early warning and alerting. I'll read our sentences here because I don't want to deliver a wrong message. But this is a quite hot topic, let's say, in the infrastructure community at the moment. So we've seen examples both during this session and in the literature on the use of INSAR for monitoring strategic engineering infrastructure. And often this has happened in collaboration with infrastructure managers. Recent studies attempted to identify precursors to dam failures, bridge collapses, catastrophic landslide occurrence, and showed the potential to detect such anomalies in certain series. So our question as a community is how can we avoid creating false expectations while highlighting the true potential of INSAR? And the key question is when and under which circumstances can we say that a failure could be predicted based on INSAR observations?
So we were also discussing, probably some people still remember the SIG4 ISA projects to validate PS INSAR and others, say, Terra Firma validation project. And indeed, probably we could also think about the role of ISA to come up with a standard when people could, say, use this kind of wording in a scientific publications. This is quite a delicate topic because indeed sometimes some publications could even jeopardize INSAR as a whole. So it's not something I think we can really forget about. Okay, so this is probably the most important one. The other 2 or 3 points are not probably that delicate, that important to be passed to ISA. This is to me really important and okay, I'm talking about myself, but I'm quite sure that some people here, some panelists have had to try to defend, protect the INSAR community after, say, a wrong publication.
Anybody on this point?
I cannot see anything in the audience. And now Madi Mota raised his hand. Can you please unmute?
So now I have, sorry, so I found it finally. So thank you for organizing this. So what I wanted to mention that regarding the comment that also Francesco mentioned that we are happy about the next high resolution. I think for such applications, it's not the matter that we are happy. I think it should be a must because I mean when we compared, for example, the community in earthquakes and volcano with the community in infrastructure, whether it's city subsidence or all this built environment. The thing is that the products have been hugely underexploited. So, I mean, in earthquake and volcano community, I mean, the INSAR product has been accepted as a reliable product to do further geophysical analysis. We are seeing now, increasing number of publications in these thematic conferences that we are attending. But however, for example, when we compare, I mean, the situation has been improved certainly compared to the 20 years. But when we compare, for example, earthquakes and volcano, for example, with these built environment applications, civil engineering applications, so I would say that it's hugely, underexploited. And there are two reasons that we discussed. The most important reason is that, okay, it's a high resolution, it's a resolution. And on the other hand, I mean, the cost for these higher resolutions sometimes are not manageable for the industry and all these things. This is a problem. So therefore, I think, but on the other hand, I think this is the kind of application that could bring INSAR into the daily life of the people, considering all this anthropogenic, development that we are seeing. So this is the things that we should also invest more. If we want to see some future in this technology, so that, this is the thing that can bring INSAR into the daily life of the people. So, and I think there are two aspects in these things. First is this higher resolution. And the second thing is that some user-ready products, also low quality, for example, so, or first order quality, but I think, for example, if you could develop a sort of service or not at least products that, for example, because in cities, so we know the location is like, it's just like volcanoes. We could produce some interferograms, we could produce, some first information about surface displacements in the cities. Also, it's a first order, it is a first level, it's a level 1 product, but I think this could also hugely affect, the perception of the people and civil engineering communities and all these people in these ministries about the value of this technique.
Thank you. That was a very good point. Thank you so much for discussing this. I think there is Pablo Gonzalez.
Yes.
Can you hear me?
Yeah.
Perfect. I would like to put my 2 cents in this question. When and under which circumstances the failure can be predicted? Certainly not using only INSAR. That's the short answer. It needs to be coupled to the physical understanding of the failure mechanism. Otherwise, you will only be able to predict a very small subset of failures that had that particular pattern of a slow movement and accelerated, which is not all the type of failures. And we know that from volcano monitoring, which is using pattern recognition for decades and is still failing. So yeah, it's not controversial. It needs physical understanding, physical models of cohesive materials and many, many different micro and macro scale processes.
Thank you. So, Julia, do you want us to speed up with the other points?
I think I was just thinking about how to continue. Maybe you can just read out the questions that the community has seen them, and then they can follow up via email. But I think we do not have enough time to discuss everything now.
Yeah, that's
sorry for that, but the time is just too short.
Yeah, no, don't worry, absolutely. So one other important point from our community was about communicating results and their uncertainty. I think this is like a broader topic actually that involves all the different communities. So something that we feel it's really important is how do we communicate uncertainty to infrastructure and user? Are they aware of the precision, accuracy, and detection capability of INSAR? When they use our results, sometimes this is not true, sometimes they are aware, so we should put probably a bit more efforts as a community when we communicate INSAR externally. So we have a point also on the need on standardization of output products and the way the results are displayed and presented to such specialist community. For instance, there were talks and discussion on how we convert instant information in structural health monitoring at building scale and how to communicate the results to building and land managers. And then we wrote here, even if the estimation of proper error bars on individual samples of INSAR PS time series is a challenging task to perform, while providing INSAR results on specific assets, it would be important to provide some statistical figures concerning at least the presence of similar anomalies in other INSAR time series belonging to the same data set. So this is more an observation based on experience that we have been suggested to raise. If you can please move to the 5th point. I don't think we need to read this, but this is actually to support what was said during the first day in Maurice's presentation. So the concept of the enhanced continuity to provide to Sentinel-1 through the next generation for this community is particularly important. So we fully support that. Because on one hand, for interferometric application, we need to make sure that we have interferometric continuity, like technical continuity to the data that were acquired by Sentinel-1. And this was a point that was also raised during the discussion during the subsidence sessions chaired by Michele. And on the other hand, we need enhanced capability. So the concept that was defined as enhanced continuity in the first session is fully supported by us. And last slide, I promise, this is our bonus technical seed question. Can you please move to the next one? Somebody? Can you move to next? Okay. We know we were asked only for 5, but we had a 6 technical recommendations. So this echoes what was said before about EW data. So if possible, the community would love to have SLC data instead of GRD and raw data only, for at least for Arctic regions. Okay, thank you.
Okay, thank you very much, Francesca and Alessandro. So please go ahead and send your ideas. Is it okay if they send it via email to you to encourage the discussion and to keep it? And particularly as I'm involved in the Sentinel-1 NG development, it's really important that we also get the feedback from the community.
Okay.
So thank you very much for sharing this part of the session. And then we move on to the subsidence and deformation. We had also here different session conveners, which were Michele Crosetto, Ingvar Larsen, Tasio Strozzi, Maja Lieva, Jeannie Ketela, and Giovanni Nico. I think also not everybody can be here today, but I invite you now to give your seed questions and thoughts. So subsidence and deformation team, who's going to start?
Tazio, here. So we have different presenters here. Many presenters are not enough time to really coordinate everything. And yes, I think so I will try to manage the seed questions. And the first one, which is coming from this wide C-band processing, is going to be more and more used. And what will be the evolution of these wide area ground motion services? I'm not sure who is attending from the other panelists. I lost a little bit the overview. I think this question was raised by Michele, but I'm not sure if he's here because he had
He should be here.
He said he had also
Yes,
some other
sorry.
issues in parallel.
Yeah. No, no. Can you hear me?
Yes.
Yes.
Yeah. No, well, we were proposing these questions, getting not really a precise answer to this. I can just comment that most of the wide area services that are implemented in Europe, country-wise, like Denmark, Holland, etc., are based in Norway, are based on C-band Sentinel-1 data. And the question is how they are going to evolve in the future. We know that in some cases, probably Italy, the ground motion service based on Sentinel will be complemented by Cosmos SkyMed data on spot of interest. This is just an example of the evolution of such a service. I don't know if you have any comment on that.
I can maybe make a comment from the Norwegian side, or also from the European side. For the European ground motion service, as you know, is since you're on the advisory board, is contracted for the next 4 years. So the product portfolio and everything is defined for these 4 years. So, but of course, during that time, we should be thinking about evolution. And Norway, of course, within our national ground motion service, we are looking forward to evolving in the meantime, and especially taking into account new sensors. And one of these, of course, will be Roselle in the future. But in the meantime, we have NISAR coming, and we see this is going to be quite a fantastic improvement for us. Right, when we're looking at, for example, landslides in vegetated areas, we have an ongoing cooperation now with our neighbor country, Sweden, which has even more forested areas which need to be dealt with. So L-band is going to be very important for us to look forward to.
Are there any other thoughts on this topic? I haven't checked the chat. Is there some
I checked.
other stuff?
There's nothing. Not yet.
Okay.
So Marty would like to speak again.
If I may. Yeah, thank you. Regarding this C-band nationwide processing, I would just like to share my experience that it has, for example, in Germany, has opened a fantastic opportunities, you know, for both industries and researchers, because it has made people aware of the what's going on. I mean, that's a fantastic thing. The job that all the people involved in such projects are doing at the European level, because at the end, you know, this is one of the main advantages that so this product cannot be updated regularly, you know, maybe in 1 year or 6 months. But in reality, people, what they need, people, they are interested to know what's going on now, and this is then where, you know, the scientific communities and industries can be involved by higher resolution data. So it's a fantastic things, regarding this service. And regarding these deep learning opportunities, that what deep learning do you foresee? So I think considering all these, you know, all these time series, long time series, if we go for a first order product, for example, a sort of a standard time series product using even short-term coherence. Also, we know that there might be some fading effects, but I think some of these techniques, data-driven approaches that can at least, you know, somehow highlight this transient in changes, you know, would be good for this in-SAR processing and deformation monitoring. Also, we need to be careful that we don't give a sort of false alarm for early warning. But these transient detections, data-driven approach something would be very interesting. Or I mean, not only for volcano hazard, but also for engineering communities and infrastructure monitoring.
Thank you, Marty. Also, Ricardo would like to speak.
Yeah, can you hear me?
Yes.
Yes.
Yeah, I would like to add just a quick comment on the first point. I fully agree with John mentioning the importance of having L-band, but with respect to this, I would add just a little more issue. The possibility of having not only L-band, but also more than one look. Because you have seen, it was mentioned before, that in the overlapping of the burst of Sentinel-1, you may get information about north-south component. So if we want to really squeeze the information, L-band is important, but let's try to have something that gives to us more than one look in order that we can get a wide area coverage, but possibly a three-dimensional information on the investigated deformations.
Thank you, Ricardo. I suppose this is something that can go in parallel if we look at future mission, Roselle and the harmony concept. So they're both points I will write in the recommendations for this session. I move to the second point. It is about we gain with Sentinel-1 short-term coherence, but this fading magic effect seems to be a limitation. And what is the correct approach to treat them? I don't know if Ricardo is still online. Can maybe give us a first answer to this question.
Yeah, that's why I'm here. I don't want to polarize too much the discussion so quickly. I have a very clear point of view. I have also expressed during my presentation here. So, okay, I am really a little bit astonished when I hear, that after that we made a lot of effort to have a short baseline constellation like Sentinel-1, to hear that the short-term coherent, that the small baseline interference are dangerous. Now, I understand that there are some issues, but in my opinion, these issues are rather clear. If you work with multi-look interferograms, because of the complex average that you do, you have problem with your phase closing. We know for many years. In the past, this closing was essentially affecting noise. Now maybe we see something else. But the point is that we need to build up something that is defeating this closing effect. If you close and through redundancy, as I think I have shown, but not now, 5 years ago, through redundancy, you close your loops in your triple phase, then the problem is gone. And so you can use it. The short-term coherence, the short-term interferograms. So fully benefiting of the nice coherence that you get, and through this redundancy, you get rid of everything. That's my point, and it's also written in the comment I mentioned and that I share with the people during my talk. I hope I was clear enough, Tatsu.
Yes, thank you. I think you are. So proper understanding of the processing approach, appropriate noise filtering. That's what I will write here. But maybe from the audience, there are some other comments, some other answers, some other opinion.
I cannot see anything yet.
From the other panelists, I wasn't the one putting up this question, so maybe there is an idea behind that question.
Alessandro Ferretti speaking. It's worth investigating. I mean, it's a fact. We shouldn't say emphasize too much this point, because otherwise I agree with Riccardo, we pass the wrong message that, oh no, go back to 24 days, 35 days, repeat cycles, and it doesn't make any sense. So we are coming, so we could see something interesting, okay, not related immediately to a displacement, and that's interesting because it's a physical, say, quantity, and so we have to work to find the best way to deal with. Of course, if you don't work on agricultural fields over vegetated areas, you're happy. You could have the daily repeat C-band, L-band with no problem at all. So it's physics after all, but it's worth working on it. We have something to think about, so I'm happy.
Yes, so I also included a proper understanding of the physical mechanism is required, and this needs probably further investigations. Maybe also campaigns at different wavelengths or with ground truths, or
exactly that's yes.
Similar is done in other experiments with ESA.
Also related to this topic, Marcus is asking whether we need targeted studies for closure phase.
Yes, that's what we were saying at the moment, yes. We put it into the recommendations that you have targeted studies for.
And just one comment to add to that, I would say whatever solutions we come up with as a community for this, they also need to be appropriate for areas where we only have short-term coverage. So just using longer-term interferograms isn't a solution everywhere because it's not applicable everywhere.
Thank you. Sorry, I'm still writing. Are there any other questions or comments from the chat? Raise hand. Good, so I move to the next point. What deep learning opportunities do you foresee both for in-SAR processing and information monitoring? And we had already an answer or a comment from Madi before. Okay, maybe from the other panelists. I don't know who put up this question.
Yeah, I can comment on this because we saw this morning in the fourth session an example of deep learning opportunities for phase unwrapping. And yeah, we have also seen more initiatives actually to retrieve more out of the data, like we've seen this morning for nonlinear deformation, piecewise time evaluation, and we have seen this in other presentations as well. So indeed, these deep learning opportunities they seem well, they seem to improve both on the processing and the deformation monitoring side. So I think it's also the recommendation what we actually got from this fourth session is that we should stimulate the development of initiatives and methods that actually look at how to extract more useful features and yeah, information from the SAR data.
I think there are already initiatives from ESA. Maybe Marcus, you know about that, or you can say something about artificial intelligence, deep learning.
Well, yes. I mean, there are artificial intelligence activities going on in quite a few places in ESA, including in the Phi Lab, where here in Esrin, where I think that they are doing very wide. They are doing all kinds of missions and mini satellites and things like that, and also there are other initiatives inside ESA. So I think that if you want to more targeted approaches, you can just put it in the recommendations. So what?
So Kini, do you have a more targeted recommendation?
Yeah, actually, it's also welcoming everyone to think about it, because yeah, we've seen examples on the processing side until interpretation of the deformation time series. So it's also stimulation to think what we can do else here.
Very good.
Yeah, maybe I can mention here that also you can propose things to ease up in this permanently open call program where we have 1 year studies up to 150K. So you can propose any kind of innovative deep learning thing over there. But if you want many teams to focus on the same issue, then maybe you should write it down in a recommendation that I think the community should look into using machine learning in these kind of subtopics.
Thanks, Marcus. Are there comments from the chat?
No comments.
Okay. So I move to the last point, which is a very generic one. It's just I think it's now the last minute to recommend something, and this is very generous. So I say Sentinel-1 constellation is written here, but it could be a Sentinel or just is a constellation of satellites for the subsidence and deformation community. Which technical enhancement do you recommend to work on to be really adapted in a short term? So short revisit time, longer spatial baseline, spatial resolution, incidence angle, multipolarization. Was working last months a lot. I was struggling a lot with the north-south component, also for subsidence. You were assumed to be easy task to solve subsidence, but then it came out that ascending, descending were different, and just understanding the mechanism without having a third component is very difficult. So this goes into the harmony mission, so that for me, even in a subsidence session, the importance of having a mission which can deliver the third 3D the composition of the motion is important. As I said, very generic from the audience, from the other panelists, if there are recommendations that we can add at the end of this session.
Yeah, maybe I can help you, Tatsia, making it even more generic, because we have a 1 hour technical discussion this afternoon, starting on 2 on R&D preparation for Future SAR and high priority candidate missions. So you can even widen it outside the scope of SAR. So how can we benefit of synergies of multiple systems? And we have another discussion about that this afternoon.
So I think, for instance, for the physical understanding of certain mechanisms, like phase closure, maybe having a simultaneous L and C band, or as close as possible, would be important.
Yeah.
Pero me ha detto
Are there comments from the chat?
It could be that
Maybe
Philippe Durand wants to speak again, but I'm not sure if it's new or not. Maybe we can ask him.
Yes. Yeah.
Okay.
Just to comment on the previous idea of the multi-looking, in fact, if you consider having bursts that are completely overlapping, not just 2 kilometers, but the 20 kilometers, that means like to look one forward and one backward. I don't know if it's technically feasible, but it can retrieve the north-south component on the whole burst.
And the next one would be Christoph Giesinger, and probably also the last one, as we really have to end this meeting soon. Christoph?
I think I'm unmuted now, so you should hear me.
Yes.
Okay, perfect.
Yes.
Just a, let's say, small last recommendation on, let's say, on the general enhancement probably of Sentinel, and want to bring up a point that I also mentioned during one of the talks in the subsidence session, that there are now also a lot of activities in the geodetic community to collocate and install ground infrastructure that is really dedicated also to Sentinel. So especially corner reflectors, but also these low-cost transponders that are now coming up. And I was wondering if this is seen kind of also of an interesting point for ESA and for the mission provider, that such infrastructure is also acknowledged kind of by the operators, so that we can bring up a kind of panel or way to make it known that we have something like we have in the GNSS, like the reference infrastructure in Europe that's maybe a bit graded also to maybe class A, B, or C. That we have such targets on ground, that they are known, that they are available also to cross-validate and bring together different results.
Okay, thank you, Christoph. Tatsuya, I don't know, do you want to conclude this part of the discussions?
No, I mean, yes, I can conclude. I can just thank all the speakers in the session and the long list of posters, which were, I mean, it was difficult on this online event to get in contact to all the poster presenters and to get comments and recommendations from that. And we know this online event very much restricted to the panelists.
Okay, thank you. Then, I think it's on me to thank all of you, particularly the session chairs, for all the work you've put in and also in putting together all these questions, and for the good discussions in this meeting. And I think some of the points will even be taken up in the next session this afternoon. Thank you very much.
Thank you also from my side, and I remind the chairs that we need one person to present the summary, 10-minute summary of the session. Well, I would concentrate more on recommendations, and we can then afterwards, if there's some things if the time is too tight, we'll work on it via email. But please let us know who's going to present and send us your slides before the closing session or summary session. All right.
Okay. Thank you all, and have a good rest of the meeting.
Thank you all. Thank you very much.
Thank you.
Thank you. Bye.
Thank you, Julia.